Good day, ladies and gentlemen. Welcome back to Emoji Economics YouTube channel. How are you guys doing? How's your day been? I hope you're doing okay. Welcome back to statistics that we're doing on the economics. All right. Last lesson we looked at the concept of probability. I think last two lessons started evaluating the concept of probability once again. And in today's lesson, we're looking at a very useful tool in calculating probabilities, which is called a tree diagram. So sometimes probability could be expressed in terms of a tree, and it actually really makes probability calculations pretty simple, to do. Now let's start with this example. So you have an example on the board. There is a particular guy, there's a particular lady that I'm going to call Suliat. All right. So again, Suliat is one of our students at the current, like right now. So you have Suliat, who has this set of probabilities. So to win a daily draw, right? So our probability is 1/1245. So which means that there are probably 1,245 people also vying for that particular draw. And then our probability of not winning it obviously is going to be 1 minus 1/1245. So which is this other guy. Okay. All right, and then to win a weekly draw, which is a different thing entirely. So our probability of winning it is 1/324. So there are like 3 to 4 people vying for that particular draw, and then our probability of not winning it is going to be 1 minus 1/324, which is 323/324. That's something that we understand, anyways. So there are a couple of questions that we need to solve. Number one is what is the probability that she's going to win both draws? Then what's the probability that she's going to fail to win either draws? Blah 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 like that. But the very first thing is that we should present this information in a tree diagram. Now, for those of you that are used to economics, game theory in economics, you would have come across presenting a game in the form of an extensive form game, like instead of using matrix format, a tabular format to present a game. So you are going to use an extensive form game, which is the kind of game tree that's used like solve for sequential games and first mover, second mover, blah 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 like that. So it's something like that, but not like like fully, but something like that. So now let's look at it. There are two type of draws. So you have weekly draw, you have daily draw, weekly draw. Anyone could come first, and because there are two different events, so that's already telling that we are looking at independent events, right? There are two separate events. So if they were dependent event, then there is one that must be coming first. So here we have the daily draw. Let me call it daily draw. Suliat can win it, right? And then it's possible that she does not win it, so don't win, right? And then after this, we then have a weekly draw. So there is a weekly draw. So I'm going to call that BVW, which she can win, right? And then which she may not win. We have not win. Okay, and then so the same thing applies. So if Suliat wins a daily draw, so she can go on to win a weekly draw. She may go on not to win a weekly draw. Do you understand? So in this case, if Suliat is not winning a daily draw, so two things can still happen. She may still win a weekly draw. Like weekly draw is what you have on this part, and then she may not win a weekly draw. So not win. Not win a weekly draw. So you can see the way it is working. So for the first one, the daily draw, she may win, she may not win. So when she's done, so if she happens to win it, so then we still have weekly draws too. Like they're still there. So she may win a weekly draw, she may not win a weekly draw. So she may not win a daily draw, she may win this weekly draw, so this falls under weekly draw, and then she may win it, she may not win it. So what are the different probabilities? So if she were to win a daily draw, so what's the probability of winning a daily draw? 1/1245. Then what's the probability of winning a weekly draw? Since win weekly draw, so this weekly draw winning is 1/324. So we have 1/324. All right. So what then is the probability of not even winning the weekly draw? So since we have weekly draw here, not winning the weekly draw is 323, divided by 3 to 4. All right, so here the same thing. Probability of not winning at daily draw, that's going to be 1, 2, 4, 3, 1, 2, 4, 4, 1, 2, 4, 4 over 1, 2, 4, 5. That's the probability. Then this guy, if she wins her weekly draw, which is same as what we have here, 1 over 3 to 4. And if he doesn't win a weekly draw, of course, 3 to 3 over 3 to 4. So this is question 1. We've been able to present the game in a tree form. So you can say it is kind of nice, right, to do this. Very cool. Yeah. So again, if it is confusing, daily draw, she can win it, she may not win it. If she wins it, she gets probability. If she doesn't win it, this probability. So she's done. So if she wins her daily draw and then she goes on to win her weekly draw, what's probability for winning a weekly draw? This. What's probability of not winning this? This. So these are the different combinations that you can have. Now, there are some things that you must know for you to know that you are correct and that the tree that you've drawn is correct. This plus this must give you 1. That's a test. This plus this will give you 1. This plus this will give you 1. This plus this will give you 1. Right? And the second test, so the first test is this plus this 1, this plus this 1, this plus this 1. So the second test, so if you know, is that 1 over 1, 2, 4, 5 multiplied by this 1 over 3, 2, 4. That's a particular combination. Then plus, so this times this plus this times this plus 1 over 1, 2, 4, 5, 1, 2, 4, 5 multiplied by 3, 2, 3 over 3, 2, 4, right? Then plus open the bracket. So you're done with this particular notes. So you come to this other part. So 1, 2, 4, 4 over 1, 2, 4, 5, 1, 2, 4, 4 over 1, 2, 4, 5 times 1, 2, 4, 4, then times 3, 2, 3, 3, 2, 3 over 3, 2, 4. Then finally plus 1, 2, 4, 4 over 1, 2, 4, 5. This is not part of the solution. I'm just kind of proving something to you. So you've done this times this. So this times this now. 1, 2, 4, 4 times this. So 1 over times 1 over 3 to 4. When you do all of this, your answer is still going to also equal 1. That's like lets you know that what you're doing is correct. So it's just a test whether your tree is right, or not. So again, I said we don't need that. But so I've done it anyways. So B says find the probability that Suliat would win both draws. So find the probability, the prob, let me just leave that way, to win both draws. So both weekly. Okay. So what's that? It's kind of easy. So it means the probability of winning the weekly draw and probability of winning the daily draw. So the answer is going to what's the probability? So we have probability of the daily draw DD intersection the weekly draw WD. So that's all. So how do we get that? When we have intersection like this is the times. Winning, this is win, daily draw. 1 over 1, 2, 4, 5 multiplied by this is win, weekly draw, 1 over 3, 2, 4. And then the answer 1 over 1, 2, 4, 5 times 1 over 3 to 4, 1 over 403, 380, 380. Yeah, that's fine. So we're done. Let's see. She says, find the probability that she fails to win either draw. Okay, so find the probability and the prob to fail to win either draw. To fail to win either draw. Okay, so some may be like, since the probability of winning both draws is 1 over 140 whatever, so that means the probability of not winning both draws is going to be 1 minus 1 over 403, 380, and then this is going to give us what is it? It's going to give us one number that I didn't even write. Alright, but if you do this is not correct. So this is going to be wrong. Because what you're saying is, if you do this, what you're saying is that a probability of not winning both. But it's not saying a probability of not winning either. So it's just English. So probability of not winning weekly or the weekly and the daily draw. That is what is going to, that's when this one is going to be correct. But the question is saying find the probability that she fails to win either draw. So she may not win. She fails to win either draw. Like she's not winning. What do you call it now? She's not winning the daily draw. She's not winning. Or she's not winning the weekly draw. Or she's not winning. That kind of a thing. So what we are just trying to like look at here is that our probability of not winning the daily draw and not winning the weekly draw. So that's what we are going to do. The probability of not winning the daily draw and not winning the weekly draw. So find the probability as she fails to win either. So that's the like correct approach, not this other one. So I can take this guy out. So we're going to be having what's the probability of not winning? So I don't need to be doing 1 minus 1 because it's already here. Not winning this guy is 1244. 1244 over 1245 multiplied by probability of don't win, not win, 323 over 324, 323 over 324. So what's that? 1244, 1245 multiplied by 323 over 324. So we have 401, comma 812 divided by 403, comma 380. So that's good. So the final question then says, under this then says, find the probability of winning one of the two draws. So find the prob of winning one of the two draws. Okay, so that's D. Find the probability of winning. It's not a probability like this for your lecture. One of both draws. So which means she wins one, she loses the other, or she loses one and she wins the other. Okay, so that's going to be the probability of winning this daily draw but losing out on the weekly draw, right? Or the probability of losing out on the daily draw and winning the weekly draw. So yeah, how do we approach this? So DD win daily, what is it? Win daily 1 over 1245. So 1 over 1245 times not win weekly, not win 323. So 323 over 324. So either this is a situation or which is a plus. Or she doesn't win this, so 1244 over 1245. 1244 over 1245, and she wins the other one 1 over 324. So by the time you're done, right, your final answer is going to equal, let me just put the answer here. Final answer is going to equal 1567 divided by 403 380. That's going to be, so you can see it is just easy, like you just be picking the numbers, picking the numbers, and then you're going to be fine. All right, so that's that about this particular one. So the question now is, are they dependent or independent events? I already said at the beginning they are independent events. So the fact that she wins the weekly draw does not stop her from not winning the daily draw, or the fact that she loses the weekly draw doesn't mean that she's going to lose the other one, or something like that. So there are different things. The daily draw is, of course, even by common sense, is not the same as a weekly draw. So let us look at a second example before we look into other things. Boluwatife and Bisola bought 6 packs of plantain chips. 2 of the packs are snake flavored, which is denoted as S, while the rest are fish flavored, denoted as F. So they decide to allocate the packs by a lucky D, right? So the first question is find the probability that the 2 bags chosen are the same as each other. So the first one is find the probability that the 2 bags that the first 2 bags chosen are the same as each other. First two bags chosen are same as each other. All right. Then Of course, the other one, so it's find the probability that they are not the same, uh, are different from each other. So are different from each other. All right. What this is just saying that we should do is that, well, since it says lucky dip, so the first one, because you're talking about first two bags. So the first dip, like the second dip, right? So you're looking at two dips. Do you understand? So like two selections, something like that. If you understand it better that way. So the first dip, this is the first dip. So we have if you pick it, it could be snake flavored, it could be fish flavored if you pick it. So if you pick the first one, right, and then it's snake flavored. So all the probability of picking the first one is snake flavored, anyways. So how many snake flavored ones do you have? You have I haven't picked the like after your first dip, and then it happens to be snake flavored. So what's going to be the probability of picking a snake flavored chip, right? Out of like 6 packs. Now, normal probability now. So how many snake flavor do you even have? Two, right? Of six. So yeah, I'm going to having 2 of 6 for the first one. And then if the first dip happens to be the fish flavored, and then of course it says the rest are fish flavored. So you have 4 packs of fish flavors out of an entire 6 packs, right? So now the second dip, so you are done with the first dip. So the second dip, of course, is going to be like this. So this is the second dip. So in the second dip, if this one happens to be, it can also, the second dip can also be snake flavored or fish flavored. Here too, now if you pick snake flavored first, your second dip could either be snake flavored or fish flavored. If you pick fish flavored first, your second dip could also be either snake flavored or fish flavored. All right, so let's go. Now look at the second dip. You have this question. This question did not say which replacements or without replacement. So, but since it didn't mention anything about replacement, so it is the case that there is no replacement. So you pick the first one, right? And then they didn't replace you, you're picking the second one, which is like a sensible thing to do, get that kind of thing. So if you're picking S the second time after you picked S the first time, now remember that you've taken one S out of the whole thing. So in the second dip now, your total is 5. Like we've done all of this is probability with replacement without replacement. Total is 5. And since the probability that you've picked S before, so the remaining one is going to be 1. So you are going to be having probability as 1/5, right? And then if it happens to be fish, you picked S the first time, so you've not picked any fish at all. So you are still left with 4 of fish flavor, so 4. But the total now is 5 because you picked something before. Now this guy 4/6. You went to pick fish before. Now, if you happen to pick fish again, so you're going to be having 3, right? Because you picked one fish over, you should reduce the total to like 5. Then this guy, you didn't pick fish before, and then this one is remaining 2 snake flavored out of the total is now 5. So this is it, we're done. And if you do it again, this plus this is 1, this plus this is 1, this plus this is 1, and then if you do the other thing I told you to do, you're still going to get 1. So with this, we can solve the problem. Despite the probability that the first 2 bags chosen are same as each other. So it is the case that the first 2 bags are either both snake flavored or are either snake flavored, right? Or they are either fish flavored. So first 2 bags. So we are going to be having for A. So the answer to the question is going to be this 2/6 times 1/5, S here, 2/6 times 1/5, right? Then plus, if you want to pick fish flavored, 4/6 times 3/5. So it's either this or this. And then the answer is going to be, I think it's 2/30 plus 12/30. And that's going to give us 14/30. 2/30 plus 12/30. Is that the answer? 14/30. Right? And then you can divide this to give you 7/15. So you see that it's easy once you've done the tree. And the second one says, find the probability that the first 2 balls chosen are different from each other. So which means if this guy is S first, and this one is F, so we are doing 2/6, 4/5. 2/6 times 4/5, then plus, so we are done. We went S here and F, that's what we did. So now we are going to be going F here and then S, since there are two different bags. Okay, so from here to here. So F here is 4 over 6, and then the other guy is 2 over 5. So you have 4 over 6 times 2 over 5. So 2 times 4 is 8, so you have 8 over 30 plus 8 over 30, which is 16 and 30. This is going to give us 8 over 15. I think that's all about that particular question. Is there anything else? Yeah. So are both events dependent or independent events? It is clear now that both events are dependent events. Like what you're going to get here, what you're going to get in your second tip depends on what you must have gotten in your first tip. It is like so clear. Do you understand? So clear, so clear. Yeah, that's about that. So if you have questions, please let us know. Put them in the comment section. The next thing we have to go to now is the assignments for this particular lesson. Here's our assignments. In a certain district of a large city, the probability of a household suffering from a break-in, like a theft, is 0.07, and the probability of a car stolen is 0.12. So assume both are independent events. A, present the outcomes in a tree diagram. B, find the probability. So this probability, I don't just want to write it full again. Find the probability that a household falls victim of both crimes. A household falls victim of both crimes. Then C, I don't want to write the whole thing. So find the probability that a household suffers only one of both crimes. A household suffers only one of both crimes. And then D, find the probability that a household suffers at least one of both crimes. At least one of both crimes. So you have to solve these problems with the aid of a tree, with the aid of the game tree. All right. Then number two during the game tree. So just common sense, and you can think it through. Afusat drives a car to work if she can get it to start. Okay, hopefully Afusat is going to see this video. Now, when she remembers to park the car in the garage, the night before, it starts the next day with a probability of 0.95. When she forgets to do that, to park the car the night before, the probability is 0.75 that the car starts. Okay. Now she remembers to park the car in a garage. She remembers to park her car in a garage 90% of the time. Is it garage or garage or what is it called? Whatever. All right. Well, she remembers to park her car anyways. Where she should park it 90% of the time. So find the probability that Afsat drives her car to work on a given day. So whether she forgets to park it or she doesn't, or she remembers to park it, what is the probability that she drives her car to work on any given day, right? So yeah, that's about that. As an addition, not an assignment now. In addition, if you have what do you call it now? Dependent events. So how does the game tree look like? Okay, so you have this, you have this. So let's say you have event A and B. So this is event A. That is event A is going to happen, and then this is okay. Let me put it here. So this is event A happening. This is event A not happening, which is otherwise like same as event B. Sometimes, right? So event A happening, event A not happening. Then you have event B if they are dependent events. Event B happening, probability of event. So we have probability of event A. So this is going to be event B happening based on event A that has already happened. Then here, event B not happening based on event A that has happened. Then here, event okay, B happening based on event A that did not happen. Then event B not happening based on event A that did not happen. All right, so like if it's dependent event, this is just what you like. That's just a summary, like a format, kind of a summary for all of those things. So then all of this, this is probability. The probability of event A, probability of event A not happening, probability of event B not happening because event A has not happened. Blah, blah, blah. Just filling the whole thing by itself, like something you know how to do. Thank you. See you in the next lesson. We're talking about what is it? Talking about a particular type of variables. See you there. Thank you very much for coming. Watch out. Bye.